Hello everybody and welcome to the lecture series on Pharmaceutical Organic Chemistry 2, and today we are going to discuss the Huckel's rule for aromaticity. Now this rule is based on Huckel's molecular orbital theory and gives us a very good idea about the aromaticity of a compound. So this lecture is going to be an elementary account for understanding the aromaticity of any compound, any particular compound. And in the lectures to come, we will try to solve some problems and get a thorough understanding of this concept. So let's dive in and try to understand the Huckel's aromaticity. So a compound can be considered as aromatic if there are some conditions, like the compound should be cyclic in nature. This is the first and foremost requirement. If a compound is non-cyclic, that is not going to be aromatic at all. Okay, then the compound should be planar. It should be conjugated. We'll just come to these in a moment. And the next requirement is that it should have 4n+2 number of pi electrons. Okay, so now let us try to find out if a compound is planar and conjugated. So the criteria for this would be the continuous overlapping of p orbitals. Now what does that mean? Let us have an example of the benzene ring. So in the benzene ring, we know that there is the presence of alternate single and double bonds like this. So these are the pi electrons in the benzene ring. Okay. And what they do actually is that they give rise to the pi cloud by a free movement of these electrons into the overlapping p orbitals. Okay. Now, due to this continuous current of these electrons, we can say that the compound is conjugated in nature, and the continuous current of these electrons is a consequence of the planarity of this molecule. So this is important. Okay, now if we are clear with the concept of planarity and conjugation, now let us come to the understanding of what this 4n+2 means. Okay, so this n, it can be any integer, which can be 0, 1, 2, 3 or any other integer. Okay, so these are some of the criteria for aromaticity, and we can understand these with these examples. Okay, so let us take benzene as the first case. So we have seen already that it is planar in nature and it is conjugated in nature. Obviously it is cyclic. Okay, and we have already seen that these are the pi electrons of this compound. So if we just count them, 1, 2, 3 and 4, 5 and 6. Now the criteria for aromaticity, as we have seen, is the formula 4n+2. Now we have seen that there are 6 pi electrons, so we can put it as 6. Now there are two ways in which we can solve. The first is, let us solve it for n. So it would be 4n equals to 6 minus 2, that is 4n equals to 4, which gives us n equals to 1. So n is an integer. Now the second manner would be that we put the value of n equals to 1 and we solve for this equation. So we get 6 equals to 6. So in both the ways, we can see that n is an integer, and therefore we say that benzene is aromatic in nature. Okay. Now the next compound is naphthalene. Okay, so if we talk about the aromaticity of this compound, we can again see that this compound is planar and it is conjugated. Now, quick fix to see if a compound is conjugated or not is to see if it is containing alternate single and double bonds. And if it is containing alternate single and double bonds, you can say that this compound is conjugated. So, naphthalene is exhibiting this thing. So, what we'll do is we'll try to find out the total number of pi electrons here. So, what we have to do is we have to just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so we have a total of 10 pi electrons here. So if we solve it for n, so for n equals to 10 minus 2, that is 4n equals to 8. So n equals to 2. So we can see that n is an integer and therefore naphthalene will again be aromatic. Okay. So this is how we can find out if a compound is aromatic or not. Now what about non-aromatic compounds? How do we find them? That is quite easy. Okay, so the first and foremost criteria for aromaticity was cyclicity. So if a compound is not cyclic, it is not going to be aromatic. So we just omit this mandatory condition and we just have these two conditions. That is, if a compound is not planar or not conjugated, we can say that there will be an absence of continuous pi current or continuous overlapping of pi orbitals, and therefore the compound will not exhibit aromaticity. So for example, this cyclohexadiene. Okay, so what we can see is that there are 1, 2, 3 and 4 pi electrons. Okay, now we can see that there are no pi electrons here, and as a result we can expect these carbon to be sp3 hybridized. Now we are already familiar that the carbons that are containing these pi bonds would be sp2 hybridized, and this was a mandatory condition for us for aromaticity. So in that case cyclohexadiene will be non-aromatic. Just change the color. So cyclohexadiene would be non-aromatic in nature. Non-aromatic. So in the same manner we can have cyclopentadiene as well. Okay, so just as in case of cyclohexadiene, the cyclopentadiene again contains an sp3 hybridized carbon, and therefore it is again going to be non-aromatic. Okay, so now let us come to the anti-aromatic compounds. Now these anti-aromatic compounds have some interesting things. For example, they fulfill most of the criteria that is for aromaticity. So they are cyclic in nature, they are planar in nature, they are conjugated in nature. So all these three criteria are being fulfilled by these anti-aromatic compounds except one, and that is they have not 4n plus 2 pi electrons but 4n pi electrons. And just as an example we can see this compound is, just a second, this compound is cyclobutadiene. Now if we talk about the planarity, okay, the compound is planar in nature because all these carbons are having sp2 hybridization. Okay, so 1, 2, 3 and 4 carbons are there, and all are having sp2 hybridization. Now the compound is conjugated as well because we can see an alternate single and double bond arrangement. It is obviously cyclic. Okay, but when it comes to the Huckel's rule for aromaticity, 4n plus 2, now the total number of pi electrons is 4. So in that case n comes 1 by 2, and which is not an integer. Not integer. Okay, so this compound is obviously not aromatic. Why? Because it is not fulfilling the 4n plus 2 criteria. But we cannot say that it is non-aromatic. Why? Because it is fulfilling the three criteria, that is cyclic, it is planar, it is conjugated. But if the total number of pi electrons satisfy the condition, that is 4n equals to 4, or whatever the total number of pi electrons is, where n equals to an integer, then we can say that a compound is non-aromatic in nature. So in that case, 4n equals to 4, which gives us n equals to 1. So now you can see that it is satisfying this 4n formula. So we would say that this compound is anti-aromatic in nature. So these are some of the elementary concepts for the Huckel's rule of aromaticity, and in the next video we'll try to solve some problems so that you can get a thorough idea and understanding of this concept. Thank you very much.